This is my test setup for testing the home-built balancer. I have basically 5 items here. One is the modified skill saw. I have removed the battery from it and added wires straight to this power supply. That way I can vary the voltage, which varies the RPM. Also the blade has been painted black, and 30-degree intervals holes have been drilled. Added some bolts and nuts to it, and that way you can add, remove nuts or washers and modify the amount of imbalance and see how this unit, the propeller balancer, detects it and does its calculations. Right in front here, that should help it focus. It's basically an LED retroflective sensor. Retroflective means it emits an LED beam, and it is searching for a reflective material, which is a reflective tape here. And when it's at its 0-degree point, it fires off a signal which goes to the propeller balancer. So you know where the 0-degree point is, and based on the consistency of the time, that's why you keep a constant RPM, you know where you are at any one time on the blade, basically. So let me fire it up. It'll just take a few seconds to boot up the propeller balancer. So it says here that we have 0 RPMs, which makes sense. Let's fire it off. I'll have to just power it and give it a bit of kickstart. There's a bit of a lock rotor condition here, which creates a lot of surge current in the beginning. So we have 2,346 RPM as an average being detected. 120-degree point is our heavy point, and 0.32 is inches per second. And we will look for the 120-degree point here, which is right over here. So now we'll go opposite and look for a 300 and add a washer. Rather a nut. And we'll fire it off again. And now we see that the RPM is 2368, 346 degrees, but really this doesn't matter that much because your inches per second is actually 0.01, which is very small, insignificant in the propeller and engine balancing for airplanes anyway.